2008 Chevy Traverse. This car was having multiple issues and went to the shop, had a 30300, 305, 306, 303, which is a multiple, basically, you know, both banks are affected. And right now the check engine light is not on. I'm not sure if there are any pending codes in it. It has a P0122 total pedal position sensor, then a catalyst low efficiency bank 1, and then again total pedal, and then a catalyst low efficiency bank 1 again. And she got new spark plugs, and car was running great. On the way back from work, pretty much car failed on its face. She couldn't drive it more than 20 miles an hour, and she said the car is making kind of strange noise. I'm not sure if this car has a chain. I was a little afraid the chain went out, but she said that engine still runs, but at the idle sounds okay, but once you accelerate it really makes some crazy noises. And my next suspicion is basically plugged up exhaust, quality converters, and I have my vacuum gauge hooked up, and see it's in my intake, and we have like 9 inches of mercury of vacuum. So pretty much this thing can't breathe at all. This is completely plugged up, and I'm gonna use a first look sensor just to put it in the intake, just to see the pulses and make sure that everything is okay there. But we're gonna need a new catch on this thing for sure. Well, I'm not sure yet, but I mean this is the first telltale that you know something's not right. And we can do the fast wide open throttle and see this needle should go down and recover pretty fast, and if the exhaust is plugged up it will kind of move very slowly. I got now the needle fluctuates excessively right now, which I don't like to see it. Maybe it's because I can now have a pretty long hose all the way into the cabin of the car. So let's just see what happens when I do wide open throttle. See that? I mean, right now there is no vacuum at all, pretty much. I mean, this thing should go all the way like a 20 and comes back. I mean, sorry, should go straight to 0 and then go back to 20. Yeah, this is not good. Okay, let's look at some data. I'm just going to go straight to a OBD2, and I just want to see the fuel trim. Generally, if one catalytic converter is plugged up and the other one is not, then we're going to have a difference in a fuel trim. The side that's not plugged up is going to get more air from the bank that's plugged up, and that's going to be like, it should have like a lean mixture on it. Just go to codes again and see if anything wrong. No codes. Okay. Let's see, current data. Can actually look at the maybe mass airflow sensor. I'm not sure what's the size of the engine, but mass airflow. Okay, the bank 1 looks a little negative, as well as bank 2. So there's not a lot of differences in a fuel trim. I was expecting to see if, you know, if one side, if one bank is more plugged on than another, you should cause a problem. Now this is a V6 engine. I'm not sure what the size is, maybe 3 something, but the grams per second 7.8, that's actually too much. I mean, this airflow, this mass airflow sensor is reporting too much, looks like. That's interesting. I mean, this is way over the limit. This should be. I mean, even for like, you know, V8 engine is a 5.6, it should be like 5 point something, but this is way too much. Let's actually go ahead and unplug the mass airflow sensor and see what happens to this car. And this is a 3.6 liter engine. You know, they should. I'm not sure even if the exhaust is plugged up, then it should underreport, because there will be not enough of the airflow. Engine doesn't breathe right, but this was pretty much double the airflow. Let's now I just got it unplugged. It's still the same. And the fuel trim is going nuts now. Let's shut it off. Okay, I guess it doesn't like when the mass airflow sensor is unplugged. Well, this is crazy. I mean, this should not be this much. It's going very positive at the wide open throttle. Okay. I don't understand why this mass airflow sensor reporting more airflow than there is, but let's go after the exhaust. As I said, I'm going to use a first look sensor. This unit is made by Sonex. This is a very nice first look sensor. It comes with multiple attachments. You can screw it to the end of the unit, and this one will work just fine. I'm actually right in the middle of my intake. This is the access for a brake booster hose. So I'm gonna get the sensor there, and also I have my Pico probe, ignition probe. I'm just gonna use. I don't even know what cylinder this is. I don't care. I just want to have a sync at this point, and I just want to see my pulses. I should have nice 6 even pulses between each ignition event. And simply I'm going to plug all this to the scope, set the scope up, and then we'll look at the waveform. Let's go start the car. We already see nice ignition waveform. Now we're going to a change. We're gonna, as I said, I never use a trigger until I get my my waveform on the screen. And now it's set. Now I'm going. Now I need to see another second ignition waveform. There you go. So that's 720 degrees of crankshaft rotation. Now I'm gonna bring my first look sensor. I'm going to go 2 volts and see what happens. Now we can see there's a lot of, let's see here, see if this is changed. This is okay. 2 volts is a little bit too much. Let's go down. Okay, and let's do 200 millivolts. Okay, there's a lot of noise in this waveform in first look sensor, but we do see some humps, some pulses basically. So what I'm going to do next, I'm just going to stop this. We can see 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, and 6 peaks basically from each cylinder, and then one again. Now what we're going to do next, we're going to filter this signal a little bit, and let's see here. Okay, this is much better. now we can see that we do have a, this is our picker, is such a nice scope. Got a 1, 2, 3, 4, 5, and 6, and then the same pulse again. And let's go run this a little bit and see if we can. Now we can see that I don't see excessive difference in any of the pulses. The one is too much, higher than another. But there's a lot of, we should not see this. The pulses should. It's almost like you can see the differences in changing in a vacuum inside the cylinder, inside the intake manifold. And let's just stop this for a second now and see. So again, they're pretty nice and even. Again, I don't see one that goes up or down too much or indicate a mechanical problem in the engine. So let's see here. Here's something interesting in this waveform here. Let's change this a little bit. Okay, so when we look at this waveform here, so see, got a 1, 2, 3 pulls, and then 1, 2, 3 pulls. So definitely in this waveform we can see that one bank is breathing and another one doesn't. It seems to me anyway. So when we put this cursor here, and then I put the cursor here, we obviously see a difference. And they're lined up, and then here as well. See all that? Let me shut the car off, it's getting hot. Okay, so again, here, here, and here. And now this it's kind of, now it gets better, but definitely we can see same repetition where one bank of 3 cylinders have a low pull and 3 cylinders have a higher pull, and so that indicates problem with the breathing. Again, it's not consistent, but there is some repetition there. You can see here this one has again, and so anyhow, we will go after a, so you're gonna here, after our exhaust. You can see here as well, here, and here, and these are longer here. So now, because, now here's a problem. Let's just, the reason why this is because the engine is changing the RPM, and the waveform is kind of, it's almost like a wave, goes up and down. Let's actually do this by adding more time, and you'll see, you should be able to see, let's kind of, the whole waveform actually, it's like one big wave because of change in the intake pressure. See right here, we can't see anything at all. But now this is interesting here that we have some changes here and here in the same area a couple of times, and here these are pretty decent actually. And but anyhow, yeah, it's not in the same cylinder. It's kind of goes in between different cylinders. I was expecting to see this waveform to go a little bit up and down if the cylinder changes more. I mean, the RPM changes more. That's where we would see it. But let's just zoom in a little bit more here, and let's now change it. Give us a little bit more detail, and oh, it's pretty even actually. Now we can see more difference in a higher peak up here. You can see 1, 2, and 3, and 1, 2, and 3. It's kind of changed. It's interesting. But anyhow, let's go ahead and here 1, 2, and 3, and then 1, 2, and 3. All of a sudden, it's almost like the waveform flipped, and now we can see the different peaks on the top instead of at the bottom. Definitely here. So you got 1, 2, and 3, and 1, 2, and 3. I'm not sure why did that happen, but again we can see that one bank it's definitely breathing less than another. There you go, see that? Okay, so it's also, I'm not sure why that happens, but anyhow we see difference now. Now if I'm smart enough, I could actually figure out like what bank this one is if I have the firing order, and then we can divide this in 4 and then figure out where is the intake for this cylinder. I'm not sure if I'm going to be able to do it or not. I'm going to embarrass myself, but it's okay. So let's go ahead and try it. So this is when this is peak, and then cylinder goes down. This would be a right here. It's the end of the expansion stroke. Here should be a our exhaust, and that should be intake. Let's see. Okay, so okay, yeah. So the cylinder, the piston. I'm sorry, piston goes down, and then piston goes up during the exhaust stroke, and then it goes down. So this should be my cylinder here. So now again, I'm now a little confused because this bottom line looks okay. I'm not sure why I have a difference on the top instead of bottom, but I need to see which cylinder this is, and one that I got a sync on, a number 2 cylinder, and so this is number 2, and this should be my intake pull on number cylinder number 2. And again, it's a little confused right now because I don't see that same waveform as I used to see it. I'm not sure why. Let's do this again real quick. I don't want to bore you guys too much, but it's kind of interesting. I want to see if I can figure out what bank is plugged up. Let it roll a little bit and see how it goes in waves up and down. That's, you know, because it changes in the pressure and in the RPM of the engine. If I can get steady RPM, just a couple of captures, and see if I can see that again, the difference in the pull. See. I think this is a good one here. Okay, so let's see here. Yeah, that's better, I think. Yeah, okay. So this should be the bank that has a problem here. Now let's go ahead and put these cursors here and see if you can find my And so again, piston goes down, piston goes up, piston goes down. This is my intake, so I think this is my intake from cylinder number 2. So I think bank 1 is okay. I think I'm identifying correctly. So if this is my number 2, and then next one will be, what's the firing order? Let's see here. Next is number 3, so that will be bank 1, and so this will be next pull, this will be next cylinder. This will be number 3, and it has a low pull, so most likely that's the plugged up. And this one here, let's see what. So this one should be number 1, I believe, right? Let's see. Yeah. Is it? Yeah. So number 2 and then number 1. Okay. So this is number 2. This should be number 1, and this should be number 3. So the 1 and 3 and then 5 here. So I think this makes sense. It does to me. I believe I'm doing this right. So this all represent here and here and here represent a bank 1 that's plugged up. Even though I don't see any differences in a fuel trim, which I would expect to see that. Alright, so I think what next I'm going to do, I'm going to pull a spark plug out of number 1, and so number 1 I'm going to do insular pressure transducer test and check the back pressure and see what we're going to have. I have my pressure transducer hooked to a cylinder number 3. I'm just looking at the bank 1 right now. It doesn't matter what cylinder you choose, 1, 3 or 5, it's gonna give you the same back pressure. That's the nice thing about the doing this test. Just come to the spark plug that you can get to. It doesn't really matter which one it is. It's gonna give you the same results. And then we're gonna move to bank 2 and do the same test. We will look at the exhaust pocket in our waveform. And basically we're gonna look at the pressure during the exhaust stroke on our waveform. Now I got my pressure transducer hooked up to my channel 1 now, and I'm gonna turn off the channel 2. Actually, you know what? No, I'm gonna turn it off. I don't need it. I could. Yeah, I don't need, because I have to. If I would crank the engine, then I could have my first look sensor as well. But since I'm going to have an engine running, I think it's going to be useful. So we're going to change this to our WPS 500 and the range 1, and then we will go to a around 200 psi. I don't need to have a sync at this time, and let's just go 100 milliseconds, and we are at 0. So now we're gonna start the car, and then we're gonna do wide open throttle. We can keep the RPM around 2000 if we can keep it at that, since the car is running poorly, and then do quick wide open throttle, and then we're gonna check the back pressure. I really could not do the wide open throttle. Let's see what happened here. Do you have anything? Okay. Oh boy. Wow. You can see right there. This is what we want to look for. This is a this is our exhaust pocket here, and we can see that this is what we're going to look at, our back pressure. And now plateau is nice and even. If like we have a maybe exhaust valve that's closing too early, this part of the waveform will be significantly higher, so it's okay. It's not a mechanical problem on the engine. But let's look at this back pressure here. We got 21 psi. I mean, that's very, that's a lot. So I'm not sure what RPM this was taken. Let's go back now. If you can, yeah, you can see this is where the RPM goes up, and we are peaking at 35 psi. I mean, it's very significant back pressure. And let's, yeah, this is even higher here, peaking at almost 40 psi. Yeah. Just when I go at the beginning, when I actually start the car, just to see what was at the idle. Okay, so this is the idle for sure, and right there we should be at 0. This would be this is where we should be. I'm going to put another cursor. We should be down here, and you can see that you know, we have excessive pressure. That's why our like 8 psi, it would be like a 16 inches of vacuum. Very low. It's actually mine is like 12, 13 inches of vacuum. So anyhow, we have excessive pressure here. There's no question that we have plugged up exhaust. We still don't know if we have a catalytic converter that's plugged up, or do we have a plugged up exhaust. And you can see how gradually this pressure is actually rising as we accelerate. Look at all that. Look at this rise in the exhaust. So we look at this waveform here, and then it can go up, and it goes just like steady RPM, go down. Again, this was actually wide open throttle, but I mean, I just could not keep it at wide open throttle. Alright, so now the next one we're going to do, the same thing. I'm going to put the plug back into the bank 1, that's cylinder number 3. And then we're going to repeat the same test on bank 2 and the front bank. Now, if the front bank is normal, if the pressure is not excessive, then we are 100% sure that we have a plugged up exhaust, because we cannot, I mean, I'm sorry, we're going to have a plugged up catalytic converter on bank 1. Now, if a back pressure is high on the bank 2 as well, then we might have a you know, downstream plugged up exhaust instead of catalytic converter, so we have to investigate. But I don't think that's the case. Anyhow, what I'm going to do next, I'm going to put the plug back in, take the plug out of the, I guess, number 2 cylinder, put pressure transducer, and repeat the very same test. Doing a insular pressure transducer on bank 2, it's not a good option, simply because I cannot pull the coil out of it. It's covered by intake, and so I'm not going to remove the intake and then you know, install my pressure transducer and put the intake back in. In this case, I'm just went straight to my oxygen sensor. It was very easily accessible, and just because I have a pressure transducer doesn't mean I'm going to do a insular pressure transducer checking my back pressure through the cylinder. I'm just doing whatever it's easier for me to do. On the bank 1, definitely was much easier to get to the spark plug instead of going down to find a oxygen sensor. Now, since I have this one removed, I'm just going to go in a cart, start it up, and if bank 2 is plugged up as well, this oxygen sensor, this hole now is going to act as you know, open exhaust, and it should give some relief to the engine. The engine should start running a little bit better. It's going to be loud, but I should be able to rev it up, even though my bank 1 is plugged up. And let's see if that works. I can definitely rev the engine higher. I can keep the RPM. Okay. So here's my cheap 30 psi pressure transducer. These work fine for this kind of test. I already have my adapter to it. I'm just going to screw it in, and then I'm going to use a 5-volt regulator, plug it in, and I have my special probe already made on my Pico, and then I will check the pressure. Of course, at this point we can use a gauge as well, but again, I'm working by myself, so I can this will be much easier for me having on displayed on my lab scope on my screen instead of looking at the gauge. Here's my 5-volt regulator hooked up to the battery, the power supply, and then you know, one lead is, my harness is hooked up to the sensor, and then I got my leads hooked up to my scope channel 1 again, and let's check the pressure. Now I didn't use this particular pressure transducer for quite some time, so before I look for my custom probe, I'm just gonna go here back to a regular probe, and then we should have a half a volt. There you go, good. So we have half a volt. That's our 0 psi. And now let's see if I can find my 30 psi custom probe. 30 psi pressure transducer. And alright, it's around about a 0. It's close enough for this. Yeah, that's good. And since I can actually change, I'm gonna deactivate my, and 10 psi, let's go 20, 30 psi, that's maximum anyway. Okay, now let's see what we got. And 100 milliseconds, let's go half a second. Interesting enough, I was able to keep a little bit of higher throttle at this point. So let's see, I've seen it already. Holy crap, wow. Yeah, this is 30 psi on this bank as well. Wow. Okay. This is the wide open throttle. Let's see, steady RPM, got 20-25 psi. Yeah, this side is plugged up as well. And that's why when we pulled the oxygen sensor, it was running better. And yeah, as soon as I started up, this is at the idle. There's a 0, it went up to 3 psi, and then up to 8.5. This is excessive pressure. And then it's no question. Now the question is this plugged up exhaust, or is it plugged up? It's both current converters are plugged up. So next step will be actually, now at this point I have to remove one of the downstream oxygen sensors from either bank, whichever it's easier to me to get to, and check the pressure there. And if the pressure is low downstream, then our catalytic converters are plugged up. If the pressure is still excessive behind the catalytic converter, then we have a plugged up exhaust somewhere downstream. There you go. I got the downstream exhaust unplugged, removed, just disconnected. And as I'm taking it apart, all these pieces of catalytic converters are actually everywhere. Now the question is, there. Oh Lord. Yeah, this thing is completely plugged up. Get a vacuum cleaner, clean that up. Okay. What a mess. Look at this. Oof. Okay. Now, to get this cleaned up really well, see how much did go downstream even further. Hope not too much. And it seems like this is all of that converter, so I assuming it's, you know, bank 1 converter. What we can do now, since I still have my pressure transducer in catalytic converter on bank 2, we can start the car real quick and check the back pressure. If that converter is nice and open, then we're just going to replace the one on bank 1. I have my lead hooked up to the pressure transducer again on the where the oxygen sensor is, and let's go ahead and check the back pressure now on bank 2. We were at the around 20 psi, so let's see what we're going to do now. So by the way, I did clean up the exhaust. That was actually a third catalytic converter, and all the contamination was actually piled up at front of it, so I literally just took the garden hose and flushed it out, and nothing actually came, it didn't pass through the deeper into the exhaust, luckily, so that's okay. Now the plan is to now we're going to start the car and see what is the back pressure of bank 2. It will be now kind of hard to figure out which bank is actually completely destroyed, since most likely now both banks are not going to have any obstruction. So what I'm going to do when I remove my pressure transducer, I'm going to take a boroscope and take a look into the catalytic converter on bank 2. Now I'm saying that most likely they will not, both are going to be wide open, because, you know, pretty much whichever catalytic converter had collapsed, all the pieces are already downstream, so it's pretty much wide open now. And see, let's go ahead and just do that real quick. Much better. And let's see here. That's a little peak. It's kind of averages around 3.6 psi wide open throttle. That's okay. Could be a little less than that, but I think that's fine. Now, and this is the idle now. At the idle we were already elevated before. This is when we got it to start, and it was pretty much at this diagnosis zero. Was based a little bit of experience just by listening to the engine, how it breathes and all that. My suspicious was the plugged up exhaust. Using this was such a severe, I would say, probably like a 95% was completely plugged up. And vacuum gauge is a very valuable tool in this case. You can see where our vacuum was around, I know it was like 14 or 15 or something like that, and when I did wide open throttle, it pretty much went to 0, and it barely recovered, went back like to 5 inches of vacuum. On the normal running car, vacuum will be around 20, and then you snap the throttle, I mean literally goes like a 0, and then it goes to maximum vacuum, and then it goes back to idle vacuum. So there will be like this, this, and this. That's what needle should do on the normal running engine. When you wide open throttle 0, close the throttle, full vacuum, and then an idle vacuum. On this car, I mean, it was, when I snapped it, it went to 0 and never went back down. Actually, it went to 0, never went back to the maximum vacuum. It just kind of was kind of steady around 5 or 6 inches of vacuum. So anyhow, that's another good test to do with on this severe case. It's not always the vacuum gauge is not always the 100%, but on this it was pretty obvious. Fuel trim, it wasn't not much that I could tell about fuel trim. My flow sensor was completely messed up. I didn't check the reading right now on these. I have another car to work on. But anyhow, the plan is to repair the catalytic converter and that's it. Now, you know, plugged up exhaust, it's never the cause of the issue, it's the effect, and the effect was basically the misfire. I talked to her again, and she said she drove the car for 2 weeks with a slight misfire. She didn't make a long trip. She was thinking maybe she'll be okay if I just go around town, and so finally I guess got worse. So she took it to the shop, they did a tune-up on it, and ran great, and 2 or 3 days later it completely just shut off, and that's the time when the bank one catalytic converter completely collapsed and just pushed all the pieces and parts down to the third downstream catalytic converter, which is kind of interesting that it has a catalytic converter but there are no oxygen sensors on it at all, which was kind of, you know, it kind of saved the rest of the system to be contaminated. Everything was kind of plugged up in front of it, so literally I just dumped it out, got the garden hose and flushed it all out, so it's wide open now, so that would be fine. And that's it. Alright guys, now the misfire is no longer going on. The engine runs great, so I don't have to worry about if I replace the catalytic converter, is it going to get plugged up again, because now engine runs okay, there's no misfire anymore. So that ignition misfire was a reason for the misfire basically. And alright guys, that'll be it. And that was also a good example where, you know, when we do a back pressure, when we do a exhaust back pressure test, we have an option to get into the cylinder and measure the pressure transducer, or of course unscrew the oxygen sensor. Some people even can drill the hole in front of the catalytic converter, get the gauge there, and they can plug it up and weld it. I don't have a welder, but that was a good example where, you know, the more tools you got, the easier it gets. And you know, again, just because I had a pressure transducer, I didn't have to go into the cylinder again, because it was a lot more difficult, of course, to get to oxygen sensor. So whichever works the best, whichever component is easier to get to, that's what you're gonna end up doing it. So, but again, more experience you have, more tools you have, easier it gets. All right, guys, thank you, and see you next time. Bye bye.